checkout of a BTU TCA54 furnace. It was originally a hydrogen furnace and we converted it to nitrogen. It runs a 3615 controller and has quite a bit of gas flow capabilities. We have what used to be the hydrogen control system we've modified so that when we use it, it'll come up and you purge, and instead of waiting for a 30-minute purge, it'll purge in a few seconds. So we've converted it to where all the inputs are feeding nitrogen now instead of hydrogen. Coming through here, it's a standard PC, talks to the control with the RS-232. It's a BTU 3615 controller, which has 6 PID loops for the zone controls and 1 PID loop for the speed control. And if you look at it on the screen here, we have all the zones set as you wanted for your reflow recipe, and it's 10 inches a minute. All zones are in control except zone 6, and because zone 5 is running 490 degrees, zone 6 right next to it is carrying more heat over than its current set point. Then coming around the control system, we've got the 3615 here. Next to it is a BTU overtemp, which is a 6-zone overtemp. So what it does is, in the event we get a failure of a Krytom relay, which is the electronic relays that control the heat, if one of those were to short out, the overtemp will sense that and knock out the main heat contactor so that you don't melt the muffle. Then coming around, as far as the gases, this was DA, which is now nitrogen, which goes into the muffle through a bunch of sparger lines here. Then we have our gas pressure controls, and then you have your individual flow controls, which you can set wherever you want. We have them set for your recipe. Then coming here, because this furnace is a nitrogen, or was a hydrogen furnace, it's built with many more baffles. This one has 7 baffles, because in a hydrogen furnace it's critical that the atmosphere is maintained and you do not end up with getting oxygen in there where you could have an explosive event. Then we have sensors on this. This is input for the water cooling. Should the water fail, you have an alarm to warn you. And a similar thing with the air. In your case it's nitrogen. We're testing it with air now. So when we disconnect that, you can hear the alarm. And what we have a failure on the atmosphere control panel, and up here we have an alarm. And let me hook that back up. Now I got to rehook the nitrogen or it will not clear. So when we hook our gas back up, now we have to clear this and repurge. So we have our gases back on. Then over here, we come in the computer and we can hit clear. And it's clear. We have a ready light again. We go back to our temps, and we're back on with all our temps. Come on down here. Now on the back, we have water cooling. Water comes in, it feeds through these coils in the cooling section, and it's cold. Whatever your water temp, you don't want it too cold because you don't want to end up with condensation. There are drip pans underneath with the drain that drains down here. But as long as you keep room temperature above, you shouldn't be having condensation. But this keeps it cool enough. I can put my hand on the muffle right here, and right in here we're at 500 degrees C. Then this is the hot zone. We have a transformer here that puts out 110 volts for running our computer and our controls. And on the input, our power comes in here to the main contactor, and the power you have the choice 220, 208, or 240 volts. We're currently running on 208. It should be wired for 80 amps or more. And then looking at our ammeter, now that it's a temp, we're running anywhere from 8 to about, what's the high on there, maybe 13 amps. And so it's so well insulated, you really won't use much energy running it. Now it does have the hydrogen burn-off. We've left all that in place. They're lit, but they're not necessary for your operation. Each zone has a circuit breaker, so should there be a short or something, if the heater breaks and shorts to ground, that would kick it out. And then we have a transformer that runs the burn-offs. And coming back to the computer, that's pretty much it for the checkout.